My lords, that's me, ladies and gentlemen, at the legislative drafting unit of the Intergovernmental Panel on Climate Change, they do not call a spade because they don't do simple. No, they call it a one-person operated, manually controlled, foot-powered implement of simple and robust yet adequately efficacious lignometallic composition, designated primarily, though by no means exclusively, for utilisation on the part of hourly paid operatives deployed in the agricultural, horticultural or construction trades or industries, as the case may be, for purposes of carrying out such excavational tasks or duties as may from time to time be designated by supervisory grades as being necessary, desirable, apposite, expedient or germane with regard to the ongoing furtherance of the task or objective in hand, or on the other hand, underfoot, Secretary General.
Translate it, please.
Translation, a spade. Now, I think you would like me to talk in plainer English than that this evening. And so I shall, because my kind host for tonight, who's an old friend, Godfrey Morrison, who lives up the line in Maidenhead, said to me, I've watched your videos on YouTube, and the moment you get technical, you lose the audience. And so my challenge this evening is to explain to you in between 20 minutes and half an hour at most why it is that we know that global warming caused by us has been exaggerated approximately threefold, and if you correct it and get the true amount of warming that we can genuinely expect, that's only going to be about 1 to 1.5 Celsius degrees per doubling of CO2 concentration, and that takes 150 years to happen. So you can see that if I convince you tonight, then you will see why it is that this has indeed been prodigiously exaggerated, and at the end I'll tell you who has been doing the exaggeration and what they get out of it and why they're doing it to us. It's important you should understand that as well. But I did promise Godfrey that I would try not to get technical. We will not be taking the first derivative of the Stefan Boltzmann equation, useful though that is, as you all know. I shall not be doing equations at all. What I shall be doing is some simple arithmetic so that all of you can follow the very simple argument that my team has been working on for several years, and we have succeeded in boiling it down to an argument so simple that we hope that even an audience thick as 2 short planks, let's call that the cabinet, will be able to understand exactly why it is that we know that everything we are being told about catastrophic global warming is simply incorrect from top to bottom. Now we're going to start by imagining a world which has no greenhouse gases at all. It does have an ocean. It does have land, approximately where it all is now. It does have the sun shining just as much as it does today. But there are no greenhouse gases there. Why do we do that? Because we want to know what the temperature of the Earth would be just because the sun is shining, and before we complicate it, even with the naturally occurring greenhouse gases that would have been present in 1850. Now, immediately we come upon the first of the many errors that I shall be drawing to your attention this evening. But before I even get to that error, I'm going to ask anyone who knows from looking at the papers and reading about climate change, what is the ideal global mean surface temperature of the Earth? Does anybody know? Hands up. I see no hands. Is this because, being from UKIP, you are unbelievably dense? Well, yes. I mean, no. What it means...
Room temperature, unfortunately.
Oh, very good. Thank you, sir. That's absolutely correct. But I prefer Bordeaux myself. I'm a claret man. So the answer is nobody knows. And you would think that if anyone wanted to come to us and say, ooh, but if it gets warming by 1 or 2 or 3 or 4 Celsius degrees over the next 1 or 2 or 3 or 400 years, they would start by finding out what is the ideal global mean surface temperature, because otherwise you have no benchmark from which to establish how much global warming would be a bad idea. And when I first was asked by a hedge fund in London to have a look at the science, I'd previously drifted along with this, and in 2006 they rang me up and they said, please will you look at the global warming question for us? So I went and spoke to the true believers. And I said, hey, I'm one of you. I believe in all this stuff. Can you please tell me, so I can start doing some calculations, because I've been asked to check. Can you tell me what is the ideal global mean surface temperature of the Earth? And they went all girly on me. And they said, well, you know, that's not a relevant question. And I said, well, I'm sorry, but as a policymaker, I regard that as a highly relevant question. If we are unable to discern even what is the best of all possible temperatures in the best of all possible worlds, as Candide would have put it in Voltaire's splendid book, then if we don't even know that, how can we say that letting the planet get even quite a lot warmer is actually going to cause any net harm? To which they had no answer. And that was intriguing, because it's a very simple point. And it's a point that everyone can understand. So I start with that point. They have not asked the question, what is the ideal global mean surface temperature? And what that tells you is that we are dealing not with science, but with politics. Masquerading as science and using men with beards and egg-stained lab coats with leaky biros sticking out from the front pocket, saying, I'm a scientist, so you have to believe the Communist Party line because I say so. Can I have my check now? What we're going to do is to take them on their own ground. We have established, by the fact that they have not asked, let alone answered, that very obvious central question, that this is political and not scientific. But after many years of looking at this question, I don't think that we can beat the Communist Party worldwide on the politics of this. The only way that this absolute nonsense about climate change can be defeated is by, in the way that Matt Damon put it in the movie The Martian, we're going to science the shit out of it. And the moment we do that, we face an interesting problem, which is that if you go to the average wooden top or cabinet minister and you try to explain even the most elementary equation to him, his eyes will glaze over and say, as Oliver Letwing said to me the other day when I met him outside my club, he said, we just have to do what the scientists tell us to. I said, Oliver, you studied philosophy at Peterhouse under Maurice Cowley, the most conservative, the most enlightened, the most imaginative philosopher the planet has ever seen. And you come out with a statement as crass as that. And he walked away, hanging his head, I am glad to say, in appropriate shame. But that is the problem. So any scientific argument that we have to put to you has to be monumentally simple. It has to involve nothing more complicated than simple arithmetic. Now let me ask a question. How many of you are carrying pencils and paper or some methods of writing stuff down? Quite a few. This is a UKIP audience, better educated than most. Get out your means of writing things down, because I'm going to do some sums with you which are I hope you will find the kind of thing you might have done in primary school unless you were a cabinet minister. So here goes. We start then with what the temperature would be if there were no greenhouse gases in the air at all. And the answer is, according to the official party line, 255 Kelvin. So Kelvin is the scale of absolute temperature. If you deduct 273 from it, it turns it into Celsius. So that makes it minus 18 Celsius. But we do everything in Kelvin because it does make all these arithmetics a lot easier to do. So 255 Kelvin is what they say is the emission temperature, as it's called, the temperature that exists simply because the sun is shining. Now, I won't go into how we calculate that because I would have to differentiate the Stefan-Boltzmann equation for you, and we're not going to go there. I'm just going to tell you that's the figure that in paper after paper after paper the climate communists use. So we'll start there. Now then, we have to say, right, what happens before man comes into it? We do then put some greenhouse gases into the air because there were greenhouse gases in the air before we came along, otherwise we wouldn't be here. Because without greenhouse gases, plants can't grow, and then the animals that feed on the plants can't grow, and then we who feed on the animals can't grow. So you kind of need greenhouse gases there. So how much warming did the greenhouse gases that were there in 1850, before we could have much influence, how much warming do they say, those greenhouse gases would have caused? And the answer is 8 Kelvin. So write that down. You've now got 255 Kelvin of sunshine temperature, the emission temperature. You've got 8 Kelvin of warming caused directly by the naturally occurring greenhouse gases that were present in 1850.
That's
but
not extra to the burst sun, that's instead of the burst.
No. You add them together. So you should now be up to, answer, sir, what do we get to now? Where have we got to? 263 Kelvin. Give that man a merit star and a jelly bean. Right, so very good, you've got that correct. Now, but the actual temperature in 1850, because it was the first year in which an attempt was made, and quite an accurate one, within a third of a degree probably, to work out what the actual mean global temperature was, the average overtaken over the whole Earth, it was 287 Kelvin. Now you'll see there is a difference between those two numbers. And the difference, sir, is how much? You're our mathematics geek now. 24, thank you. Another merit star. 24 Kelvin, which we haven't accounted for. Now this I'm going to call extra warming. It's called temperature feedback response, if you want the official name, but it's extra warming that happens simply because there is some sort of a temperature present. But here's the thing. The extra warming arises as a response to the pre-existing temperature, whatever it might be. And then if you add some more temperature directly by putting more greenhouse gases, the feedback will respond to that extra as well. So here is how climatology does it. They say, right, we have the emission temperature from the sun, 255. We have the directly forced warming from the presence of the naturally occurring greenhouse gases. We don't come into this until after 1850. 8 Kelvin. Then we have 24 Kelvin of extra warming, which is feedback response, to the 8 Kelvin of warming from the greenhouse gases. Now, can anybody tell me what is wrong with that picture? Sir?
Well, it's treble and there's no explanation.
That's partly right, but there's a more obvious error.
As a pack of lies?
It is, but I want you to see why it's a pack of lies. You see, feedbacks respond not only to changes in temperature, they also respond to any pre-existing temperature. And if you go outside and look up into the sky, anywhere in the world except Scotland, what will you see on a clear day? You don't get clear days in Scotland. you'll see a large yellow thing, and it's called the sun. And that is the source of most of the warming. That's where the 255 Kelvin comes from. And that sunshine comes down to Earth, and then, according to official climatology, that sunshine temperature of 255 Kelvin produces a 0 extra warming. But then, if you just put 8 Kelvin of directly forced warming by the greenhouse gases into the atmosphere, that produces 24 Kelvin of warming, and that's the error. 255 Kelvin produces no extra warming. 8 Kelvin produces 3 times itself.
Have you calculated the volcanoes?
I'm sorry?
Have you calculated the volcanoes and the heat?
Yeah, we'll come to that later, because at the moment we're doing such very basic sums that even a cabinet minister might kind of be able to grasp this. So the fact is that obviously if you've got an ice planet at any temperature below 193 Kelvin, the whole planet would be covered in ice under today's conditions. And so then you would get a little bit of feedback, but not much. So we still have above 207 Kelvin, by which time the feedbacks would be well and truly operating. We have still 48 Kelvin, where they're saying no feedback response is produced at all. But you suddenly put greenhouse gases in, and precisely the same mechanisms as ought to be producing a feedback response to the sun, but they say they don't realize that feedback response happens not only to any change in the original temperature, but also to the original temperature. They leave that out. Now, why does that lead to an exaggeration of global warming? After all, if they've missed out some huge source of warming, isn't that going to make things even worse? The answer, of course, is no, because we know what the temperature was in 1850. And we know 2 of its components, 255 and 8. And so we have to work out how to apportion that 24 Kelvin of extra warming between the extra warming that comes from the 8 Kelvin of greenhouse gas forcing and the extra warming that comes from the 255 Kelvin of sunshine temperature. So here's the question. Which of those 2 figures, 255 Kelvin or 8 Kelvin, is likely to produce the larger feedback response? Any answers to that? It's not particularly difficult. It's bound to be the sunshine temperature that's going to produce the largest forcing. So the moment you feedback. So the moment you redo this, you're then going to have absolute maximum of a directly forced warming of 8 Kelvin from the greenhouse gases, but only 12 Kelvin if we give the other half of that to the sunshine. Even then, we're being very generous in imagining the sunshine produces so little as 12 Kelvin of extra warming, when the greenhouse gases, which are 25 times smaller, also produce only 12 Kelvin of extra warming. But then if you've got 12 Kelvin of extra warming and 8 Kelvin of direct warming, then what that means is that instead of getting 4 Kelvin of final warming after you've added in the extra warming, which is what they imagine would happen, it's going to come down just from this simple calculation to 2.5, which is quite a big reduction. And that's before we really start to examine just how big the response to the sunshine temperature is in relation to how small the greenhouse gas temperature is. So that is the first major error. And you can see from doing this very simple sum that already we are greatly reducing the current central estimate, which is 4 Kelvin per doubling of CO2 concentration. A doubling of CO2 concentration produces just 1 Kelvin of direct warming, and then 3 Kelvin, they say, of extra warming, because that's what they thought by looking at the climate before 1850. And it should actually only be, at most, 2.5 before we start doing some further work. So now let's look. Yes, sir?
Could you give us some indication of what causes that extra?
Yes, of course I can. Yes, quite right. What happens is that there are many different potential causes, each of which are known as temperature feedbacks. But the one that matters, all the rest cancel out, broadly speaking, is what's called the water vapor feedback. By an equation called the Clausius-Clapeyron relation, the atmosphere can hold near exponentially more water vapor with temperature, so that every Kelvin of extra temperature of the atmospheric space will allow that space to carry an extra 7% of water vapor. Water vapor is a greenhouse gas. So that is the mechanism. But since you raise it, that leads us to another error, which I might come on to now, since you led me into it. And that is that they say that most of the warming they expect they're going to get from us putting greenhouse gases in the air will come not from down here. It'll start actually up in the mid-troposphere, about sort of 6 or 7 miles up, particularly in the tropics, where they say that the rate of warming caused by us will be something like twice, getting on for twice, the rate of warming at the tropical surface. However, this tropical mid-troposphere hotspot, I had the honour to name it, that's now the term that is used in climatology for it, does not exist in reality. 20 million different measurements with devices that go up through the atmosphere, hanging on balloons and all the way up into the stratosphere, do not show this tropical mid-troposphere hotspot. At no time in the last 80 years has that hotspot actually existed. Every model has to pretend that that hotspot does exist, because otherwise there is no significant water vapor feedback. Because if you increase the water vapor in the atmosphere down here, it makes no difference, because the frequencies at which water vapor interacts with the photons of radiation are the same, roughly speaking, as those for CO2, and there's plenty of that down here, so you're just not going to get much effect. You've got clouds in the way. It's only up there, where the air is thin, that if you were to add CO2 and it mixes through the air more or less uniformly, you could get this hotspot, but it is not there. So therefore we have a physical demonstration that this enormous multiplier to give you this 3 Kelvin of extra warming for 1 Kelvin of doubling CO2, direct warming, that simply doesn't exist in reality at all. Effectively, there is hardly any water vapor feedback. So now we come to our third mistake, which is that they've got the emission temperature wrong. And I'm not going to go into the details of how they calculate it, except to say one thing. They calculate emission temperature not only imagining that today's sunshine is shining, the same sort of amount of radiation coming from the sun, but they also imagine that the same percentage as today will be reflected back into space. Now, had I been able to do slides today, I was going to do an experiment with you, but you can do this at home afterwards. Get on your TV screen a picture of the Earth as seen from space. Then slowly close your eyes until you can hardly see anything through the eyelashes. What is the one thing that you will still be able to see before you can end up seeing nothing? You're looking at the daylit Earth from space. What's the last thing you see before it goes black when you shut your eyes? Anybody? Sorry? No. No.
The atmosphere ring around it.
No. Clouds. The leader of UKIP is well informed. Of course. Clouds. They reflect most of the light that is reflected back into the atmosphere, back into the space, I'm sorry. The ice caps will reflect very little back because they are so far north and south, and therefore the sun comes in at a very low zenith angle, and because of that you get very little reflection back from the ice caps, but you do get it from clouds. But clouds are made of what, anybody? Water vapor. And water vapor, as we've just been discussing, is a greenhouse gas. Exactly. But we started out by defining the emission temperature as the temperature that obtains in the total absence of greenhouse gases, by definition. Now, what happens then if you take the clouds away, as we must if we want to calculate emission temperature correctly? Well, the answer, of course, is that less light will be bounced back from the clouds into your eyes if you're on the satellite looking at it from space. And that means that more of the sunlight will get through and heat the Earth. So will the emission temperature, once we've taken the clouds away altogether, be higher or lower than 255 Kelvin? Anybody? It will be higher. You see, you now know more about this than about 95% of so-called climate scientists. They have never sat and thought this through. So, the emission temperature is higher. Now, when I first made an attempt to calculate this for myself, I reckoned, sort of back-of-the-envelope calculation involving taking 1 billion different parts of the Earth and doing a separate calculation for each. Great thing about computers is they can do that in seconds. It came out to 274 Kelvin. Now, my co-authors in the paper we're writing about all this would not let me use that figure because they said, that's just you. So I said, well, look, I'm going to show you that I can tell you what the temperature on the day side of the moon is by using the same technique and using the reflectance of the moon, which is about 11% of the moon's light gets thrown back. So I did that calculation, and I showed that the curve that I produced at all different latitudes on the moon is exactly the same as what a billion-dollar satellite spent 3.5 years measuring, the Diviner satellite. They could have come to me and I could have given them all the information they needed from that satellite. It's a simple calculation. So they still wouldn't let me, even when I showed them the graph, they said, that's very impressive. It does appear that you're kind of more or less right. But even so, it's too radical. Don't go there. We've got enough already in the paper. So then one of my co-authors said, oh, you may be interested, just literally a few weeks ago, you may be interested to see this paper by the greatest of all living atmospheric physicists, Professor Richard Lindzen. And he said, ooh, in this paper of 1994, he said the trouble with their calculation of emission temperature is that they do it with the clouds still there, but the clouds are water vapor, so they shouldn't be still there. Exactly the point I'd already been making. And he had done the same calculation that I had done, and he had said, therefore, the emission temperature will not be 255 Kelvin, as they say, it would be 274 Kelvin. So we now have a warrant in the learned literature for the value that I had gone to such a labour to calculate. I hadn't even bothered if I'd known about that paper. So now we rework the very simple numbers that we did before. You've now got 274 Kelvin of sunshine temperature. You've got 8 Kelvin of the directly forced warming from the pre-industrial greenhouse gases. That won't change. It's still going to be 8 Kelvin. So you're already up to 282 Kelvin. And the temperature in 1850 was 287 Kelvin. The difference between those two has to be apportioned between the feedback responses to that 274 Kelvin of emission temperature and the 8 Kelvin of naturally occurring greenhouse gases. So even if you were to say, well, let's put only 2 Kelvin onto the sun and 3 Kelvin onto the 8 Kelvin, which is still hugely balanced, hugely unbalanced as a way of doing it, then already you're now down to about 1.5 Kelvin of warming per doubling of CO2. And that's before you get a much more reasonable balance between the temperature, the extra warming coming from the sun and the extra warming coming from the naturally occurring greenhouse gases. So you see how very simple it is to show that the global warming we can expect is not going to be the 4 Kelvin, they say, in the latest generation of models. The result came out only last month and hasn't even been published yet, but I've got it. The average of 21 models, they say 4.1 Kelvin per doubling of CO2. So you've got 1 Kelvin of direct warming from CO2 and another 3.1 Kelvin of extra warming is what they say. It isn't the 3.35 Kelvin per doubling of CO2, of which 2.35 is the extra warming, which was in the previous generation of models 4 years ago. It isn't even the 2.5 Kelvin we calculated when we corrected for the fact that you have to give some feedback response to the sunshine and therefore take it off the greenhouse gases, reducing the amount by which the greenhouse gases cause warming. If you then factor in the fact that the emission temperature has been, for that very obvious reason, wrongly calculated, then suddenly you get down to 1.5 Kelvin of warming per doubling of CO2, and that is very much the top end of it. Now, all of these considerations are sufficiently elementary that is there anyone here who doesn't understand what I have just explained? Is it clear what I've said, sir? And do you think that I am making a reasonable case that there should be some sort of a feedback response to the sunshine temperature, and that therefore that must be deducted for the reason I've given from what is now allocated as the feedback response to the greenhouse gases? Now, I ask this gentleman because he is a control theorist. There's always one. They get in everywhere, you know. And control theorists specialize in the theory of what is called feedback. And this extra warming is called feedback response. And the mathematics governing it are exactly the same as the mathematics governing feedback in an electronic circuit. And as this gentleman will be able to tell you, the mathematics of feedback was originally derived by Harold S. Black of Bell Labs, then in New York, in the 1920s. And the concept of negative feedback, which he was referring to earlier when I talked to him, was invented by him when he was going to work on the Lackawanna Ferry. And he scribbled down the equations for negative feedback on his copy of the New York Times, and in the Bell Labs Museum in New York, you can still see that newspaper. They treat it with great reverence. So the theory of feedback actually comes from outside climate science, and that's why they screwed up, because it was a communist who borrowed it from feedback theory and bolted it onto climate theory without understanding it. And I think that the mistake that he made was genuine, because the paper in which he did this, which is a paper of 1984, Hansen of NASA in 1984, is very confused, and it's very clear that he doesn't know what the heck he's doing. It should never have got through peer review, but it did. And everybody, including me, until I went and started checking stuff, had believed this nonsense about there being no feedback response to emission temperature from the sun, because it's never explicitly stated anywhere in climatology we are excluding any feedback response to the emission temperature, but their definition of the climate feedback on page 1450 of the IPCC's leaden fifth assessment report of 2013 defines feedback in a most confusing way, but the one thing is clear: it defines it as responding only to changes in temperature and not to the original temperature caused by the fact that the sun is already shining. So that is the basic science of how we know that they got it wrong. So the next question is, do the great computer models that they use, do they implement any of this feedback mathematics? The answer is no. They do things in time steps trying to represent the microphysics of the climate by either parameterizations, because they don't have enough data, so they make it up, or by equations describing the various physical processes and how they interact. And they hope somehow that the feedbacks will emerge from this process. But because they didn't realize that feedback responds to the emission temperature from the sun, they don't program their models to take into account the fact that the sunshine is producing most of the feedback response that they are allocating to the greenhouse gases, and therefore saying that when we add greenhouse gases to the atmosphere, then we too would get 4 Celsius of warming for 1 Celsius of CO2 doubling warming. So that's, the models get it wrong. So why do they get it wrong? One thing they get wrong is that there are a lot of uncertainties in the climate, not least about how clouds behave. And the uncertainty, if you take a 20-year average on an annualized basis, is 4 watts per square metre. And they're only looking at about 0.03 watts per square metre of effect per year from us. So the clouds swamp everything. And a paper just published by my good friend, Professor Pat Frank, in the Stanford Linear Accelerator, has demonstrated that the envelope of uncertainty, the ballpark, within which, if you make any prediction that falls in that ballpark, it might as well be a guess, because the model can't tell you anything about it. It's like having the ballpark and you don't have a ticket. You're outside, and so you don't know what's going on, you don't know what the score is in the game. That's the problem with the envelope of uncertainty, and it's 15 Celsius, plus or minus 15 Celsius. over a 50-year period. And the problem is that the predictions they're making are only about 1 to 2 Celsius over a 50-year period. That's right in the ballpark. And we're outside without a ticket. And that's why the models, and he says this in his paper, and he got it through peer review, and it was read by some of the most eminent scientists on the other side of the debate before it was eventually printed. And he says, therefore, these huge computer models on which the sole basis for climate change is predicated are useless. They cannot tell us anything whatsoever about how much global warming we are going to get. But my simple model, this simple arithmetic that I've done with you today, that does allow us to place what is called in mathematics an upper bound on how much warming we might get per doubling of CO2 concentration over the next 150 years. And it is around 1 to 1.5 Celsius. Now, is this a problem? Well, frankly, no, it isn't. We've already had kind of 5/6 of a Celsius degree of warming since 1850. It's been warming at the dizzying rate, equivalent to less than half a Celsius degree per century. It might from now on go up to all of 1 to 1.5 Celsius per century, because roughly speaking, over the 21st century, we would expect to emit enough different greenhouse gases that added up, they come to the equivalent of doubling CO2. So we're going to get maybe another 1 Celsius of warming this century. Is this a problem? No, because the warming is so small and so slow that it's not going to change anything fast enough that we can't get out of the way in time. And in any case, what difference has the 1 Kelvin very nearly of warming we've had so far made? Well, sea level rose by a terrifying 7 inches over the last 150 years. And the best forecast from Professor Niklas Mörner for the next 150 years is a sea level rise of 2 inches, plus or minus 4 inches, because there's an uncertainty in it. So we're not looking at the exotic range of disasters that they predict, even if the warming were to be anything like as great as they predict. And it won't be, because here's another mistake they made. And this is the way in which they could have worked out how much global warming we can expect to get by looking at just 3 numbers. One, what was the warming that happened from 1850 until 2011, when they did all the numbers for the 2013 and most recent assessment report of the IPCC. How much warming was there? It was 0.75 Kelvin or Celsius. Then we need to know how much was the total man-made radiative forcing, the extra radiation knocking around in the atmosphere because we put greenhouse gases in and we've cut down some trees, etc. Answer, about 2.5 watts per square metre. Then the only other number you need to know is the fraction of that 2.5 watts per square metre that has not yet produced a change in temperature. And that's about 0.6 of that 2.5 hasn't yet actually produced a change in temperature. And they can measure this by measuring a thing called the radiative imbalance, which is about 0.6. So you can then work out by how much you should multiply your 1 Kelvin of warming per doubling of CO2, the direct warming, by simply saying, right, we take the 2.5 watts per square metre that was observed up until 2011, we divide it by the difference between the 2.5 and the 0.6 radiative imbalance, which is 1.9, and what is 2.5 over 1.9, anybody? It's about 1.33. You multiply that by 1 and you get about 1.3 to 1.4 Celsius degrees of warming per doubling of CO2. Now, does that figure come within the 1 to 1.5 Kelvin we arrived at by the different method of correcting their previous errors? The answer, of course, is that it's right in the middle of that particular range. So what we've got, therefore, is by correcting these 3 or 4 errors of science, using nothing more than common sense, logic, and simple arithmetic, we have demonstrated And we're now out for peer review. We hope this will get through. If it does get through, and is eventually printed, it will of course cause huge embarrassment, because these are big mistakes of physics, you can see that. But if we get this published, which we might in the next 6 months succeed in doing, then that, ladies and gentlemen, is the end of the global warming scare, and you heard it first. Thank you all very much. God bless.